I'm Jefferson, and I will start with my dynamic analysis. So what is dynamic analysis? Well, it is actually observing the behavior of a program or a system while it's running or executing, observing how the program interacts with the operating system, files, network, and other system components, examining communication between the software and external servers to identify any malicious activities. Moving on to our dynamic analysis tools. Firstly, we have Apati DNS, which spoofs DNS requests, allowing us to find out whether the malicious executable is accessing network services. Then we have Regshot in the middle, right there, that allows us to take two quote-unquote screenshots of the system to compare the registry values and to check whether modifications were made. Then we have Process Monitor on the left, which allows us to monitor real-time events happening on a system, capturing activity of file systems, registries, networks, processes, and log activity. Then we have Process Explorer, which is a more powerful task manager, allowing us to obtain some crucial information from the malware and highlight any processes that have been signed with invalid signatures or running with different credentials, as well as telling us the DLLs and handles associated with the process. And finally, we have Netcat, which is our TCP/IP Swiss Army knife, which allows analysts to observe how malware behaves in a controlled environment in regards to network connections. Well, what are we waiting for? Let us begin. So firstly, without further ado, let's do first shot of Regshot. And then let's run the executable. Oh wait, let's start the server for Apati DNS first. Then we run the executable. So firstly, as you can see here, the live changes, we have malicious.exe as we can see under Process Explorer. So firstly, let's view and let's view DLLs. So there are a few DLLs here: Advanced Windows 32, GDI, HNet, IMM, Kernel 32, NTDLL. But one thing that I want to go into particular is actually the mswsock.dll. So this tells us that the malicious executable is trying to access network services for TCP/IP interface. And moving on, let's take a second shot first. Okay, moving on, let's view the handles for malicious.exe. So you can see that this malware is actually trying to achieve persistence on the system, as we can see that it opens a key, or it actually alters a key value for the HKCU software Microsoft Windows current version run. And this is basically telling us that every time that this system is turned off and turned on again, this malicious.exe file will run. So let's see if that backs up our claim with the form of our Regshot. So we can see that actually in Regshot, let's navigate down to the run. We can see over here that I'm highlighting current version run Microsoft syslog. So if this was changed and a malicious exe is over here, this could mean that the file actually renames itself as syslog.exe. However, that is just a claim, so now we actually have to prove it. So moving on to the host-based indicators, let's try to prove that they actually renamed itself. So let's go search for the PID. So the PID is 1144, we can put that in there, apply, and applying. Okay, so if we do that, let's also filter a create file, do that. So we can see that it creates a few files, and let's go down to here. So you can actually see that it creates a file under C, Windows, syslog.exe. So let's navigate down there and see what's going on. C, Windows, and we can see down here syslog.exe. So let's use a tool from our static analysis to check if this is actually the same file as malicious.exe. So what we can do is just drag this into here. We can see the hash is D594, blah 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 blah. Yeah, so we can see that they're actually the same file. So we can see that malicious.exe actually renamed itself as syslog.exe and put itself under C Windows. And let's move on to our network-based indicators. So moving on to network-based indicators, we can actually see that there are a few DNS requests. So for this, it's actually a reverse DNS lookup, and the IPv4 address for one example is actually, as you can see, 1.56.168.192. It is actually 192.168.56.1, and the IN adder ARPA is a special domain that is actually reserved for the reverse DNS lookups in IPv4 address space. So basically, this would give us the information that malware is actually trying to connect to external IP addresses, one of which is just 192.168.56.1. Hello lecturers, today I'll be doing advanced dynamic analysis on our malicious executable. So first we have to check whether it is packed or unpacked. As such, we will use our basic static analysis tool, PID, and check if it's packed. I've already done this step, so I've already established that it's packed with UPS and unpacked, so we've already unpacked it. So then we will be greeted with our OllyDBG. And basically, to start off, what we have here is the code first retrieves the Windows directory path using get Windows directory A and concatenates it with syslog.exe and concatenates it with the kernel32.l string concatenate A. And basically, what this is doing is this path now is copied with using copy file A, and basically this code is actually using this to achieve persistence. So it navigates down to the registry key with that of persistence, because this is the startup registry key. So it basically runs syslog.exe, which is the malicious executable that is renamed, and it runs it every time this system is shut down and turned on again. As such, it opens the key with regopen key xa, and it sets a registry value with regset value xa to ensure that this malware, which is syslog.exe with the name Microsoft Syslog, is always run at system startup using the name Microsoft Syslog. So what this basically does is trying to actually disguise itself as a legitimate process. So an unsuspecting onlookers will just see it as it's just a Microsoft process and forget about it. So after analyzing the assembly code to notice that it is persistent, now I will use OllyDBG to alter the code so that we can make this not show persistency. So in malicious, so let's show persistency real quick. So we can see with Process Explorer, I'm running malicious.exe. Then let's find the registry editor, current user, software, Microsoft, Windows, current version, run. You see Microsoft Syslog. Let's delete this. Then now let's go into our OllyDBG and start patching. Desktop and unpacked. So let's go back to the first few lines that we were at over here, and let's start patching. So to patch, what we can do is we will navigate down here until the registry set value exa, and we can actually take the call over here and take this from push unpacked to 00405094 or until call unpacked. We can use this, fill it with NOPs, and we will copy the executable and save this file, and we call it patch. After that, let's run patch and see what happens. So to prove that it's running, we go to Process Explorer, we see patch is running. And we can see in the registry editor, nothing has changed. So basically, we have shown that persistency is removed.